All right, so it's time to start talking about ionic compounds. Okay, so we've already mentioned ionic compounds a couple times. We said that we can identify ionic compounds because they contain metals. We also have said that ionic compounds are combinations, or when you combine nonmetals with metals, you make ionic compounds. But now we're going to kind of define the term ionic or ion and introduce to you the different kinds of ions and how to name ionic compounds, how to know what kind of ionic compounds will result when we combine metals and nonmetals. All right? So an ionic, or an ion is an atom that has an imbalance between its number of protons and electrons. So for example, if I have magnesium, if I have the magnesium atom there, do you know how many protons are in the magnesium atom?
I can't see the periodic table.
Okay. Does that help?
Yeah, magnesium has 12 protons.
Very good. 12 protons. Now, how many electrons does this species of magnesium have?
12 electrons.
Very good. 12 electrons. How did you know that?
Well, it has the same, you said, unless it has a charge.
That's right. It has the same number of protons as it has electrons, or same number of electrons as it has protons, if there's no charge. Now, if there is a charge on a species, like a positive value, that means that there's more positive charge here, that there's more protons than there is electrons. There's one more proton than there is electrons.
So we added a proton?
No, we can't say that. We can't say we added a proton because we don't add and remove protons from atoms. In fact, the Mg, when we indicate that it's Mg, that tells us that it only has those 12 protons. Okay? So magnesium, it's magnesium still, but if it has a positive charge, then what that really is indicating is that we have one fewer electrons, and we've lost an electron. So we had 12 protons and 12 electrons, but now with the positive charge, it's indicating that we only have 11 electrons. So we have 12 protons and 11 electrons in that species. And now this atom that had 12 protons and 12 electrons is now an ion. And ions come in two categories because you could also have something like this, for example, oxygen with a minus charge, or maybe a -2, meaning that, what do you think? How could it get -2?
-2. You subtract 2 electrons?
No, you don't subtract 2 electrons. The -2 charge means that there's an imbalance between protons and electrons, and specifically here, what we're seeing is that we have more what? If we have a negative charge, what do we have more of?
Must have more electrons, I guess.
How many more?
2?
That's right, so we have 2 more electrons. So we bring out our periodic table to remind us, how many protons does oxygen have?
8.
Good, 8 protons. So how many electrons now?
10.
That's right, 8 protons, but now it has 10 electrons with that negative sign on them, okay? So, these are not the number of protons and the mass number here. I'm just writing those down, so I'm going to put a little box around those to make sure that you see that I'm just trying to indicate the number of protons and electrons in these species, okay? So, magnesium ions, or any ion that has a positive charge, we call a cation, while an ion that's negatively charged we call an anion. Okay? So, if we want to bring these two elements together...
Why do you have a picture of a cat and a dog there?
Oh, that's a good question. You want to hear my joke?
Oh, no. Should I not have asked?
It's not the best of jokes, but it'll help you remember, hopefully, the difference between a cation and an anion. Here's the joke. So a dog goes into a restaurant and meets a cat. And the dog says, "How are you today?" And the cat says, "I think I'm sick." And the dog says, "Are you sure?" And the cat says, "I'm positive." Get it?
No, I don't get it.
Well, the cat was a cation, right? So it's positively charged, so it's always positive.
Yeah, that's not a good joke.
Well, maybe it'll help you. remember the cation, right? And that's all that we really want, is just remembering cation. Okay.
Sorry I asked.
Oh, that's all right. You can do with a few bad jokes to help you remember the chemistry. Okay, so when we have ions given to us, so for example, if I say I have an iron ion with a +3 charge, and I have an oxide ion. Now notice how I changed the name of oxygen when it's a nonmetal, right? So our nonmetals over here on the right of the staircase. Those ions, when they're anions, they change from being chlorine to chloride, or oxygen to oxide, nitrogen, nitride, sulfur, sulfide. Okay? Not for our metals. Our metals, we just call them whatever the metal is, iron, ion, but this is an oxide ion. Now, when I bring these two together, I have to make sure, if I'm bringing iron ions together with oxygen ions, or oxide ions, I have to be sure that the number of electrons that the oxygen gained is the same as the number of electrons that the iron lost. Okay? So I have to make sure that these come together in such a way that the number is the same. So here I see that I need 2 of these iron +3 charges. And if I have 2 of the iron +3 charges, that would be Fe +3, Fe +3, a total of 6 electrons that were let go. And then I have 3 of these oxygen -2. That's also a total of 6 electrons that were taken up. And the electrons are transferred from the iron to the oxygen. So it has to be the same number of electrons. Okay, very good. So from that we can predict what the resulting compound will be. All right. So how does calcium form a +2 charge?
To form a +2?
Yeah, what does it have to do to form a +2?
Gains 2 electrons.
Is that what the +2 means?
+2. No, hold on. The +2 means that I have more protons, so I must have lost 2 electrons.
Very good, because it doesn't gain or lose protons, right? How about nitrogen 3-? What is that?
That's gaining 3 electrons.
Very good, gaining 3 electrons. So we can know from the element to its ion how it whether it gained or lost electrons. Now, here's a chemical reaction. We combine sodium with chlorine to form sodium chloride. Okay? Now, what is causing this reaction to want to occur? Well, we can look on the periodic table and we see sodium. Sodium right here, element number 11. Okay? Element number 11 has 11 electrons. And I mentioned this a while ago, but I'll tell you again, even if this is the first time. Elements on the periodic table want to trade or get rid of or gain electron density so that they can have the same number of electrons as noble gases. All right? So sodium here with 11 electrons, if it can lose 1 electron, it will have the same number of electrons as neon. And this is simply because these elements, with the number of electrons that they have, are stable. We don't know exactly why, what magic's involved with why it's 2, 10, 18, 36, and 54. But if an element can have what we call a noble gas electron configuration, then they find stability. They stabilize themselves. Okay? So sodium can stabilize itself if it loses an electron. And chlorine, what does it want to do to stabilize itself? It has 17 electrons.
If it gains an electron and be like argon?
That's right. Gaining an electron to have an electron configuration similar to that of argon, right? Then that would stabilize chlorine. And so if sodium and chlorine can find each other and an electron transfer from sodium to chlorine can occur, the sodium ion will result and the chloride ion will result, and they'll hold together and form an ionic compound called sodium chloride. So let's watch this video of a piece of sodium metal right here. We're going to get this piece of sodium metal, put it into this flask of green chlorine gas. All right? Nothing happens to start off with, but we can initiate the reaction by adding just a teeny little bit of water. The water will begin to react with the sodium and release the heat, and then the rest of that heat will drive the reaction between the sodium and the chlorine. Okay? So we drop a small drop of water in there, and when it hits the sodium, there's some sand on the bottom, so the glass won't crack when the heat is released from the reaction. So there we see the chlorine and the sodium metal reacting to form sodium ions and chloride ions, and the resulting white powder is ionic sodium chloride. Some of you know that one of the main components in what we call table salt is sodium chloride. So oftentimes people will say sodium chloride, oh, that's salt. Now it is a salt, but and you might think of it as the salt, but in chemistry, any ionic compound, any metal combining with a nonmetal, forming an ionic compound, is called a salt. All right? So we don't want to think of sodium chloride as the only salt. All right. Good.